Hello, welcome back. We're going to talk about finding the sine curve and how to graph that. Um, First, let's start with finding this state the phase shift. Well, what is a phase shift? Well, that's where it's going to go right or left. And to figure this out, we're going to actually, the phase shift can help us figure out our starting point of any sine and cosine curve. If you recall the sine curve right here, um, when you have our different values, all right, we're going to go from 0 to pi over 2 to pi to 3 pi over 2 to 2 pi. All right, that's where we have our normal sine curve and cosine curve always start. Now for sine, as we plug in the 0 for sine, all right, this is y equals sine of x. All right, we get 0, then it goes to 1, then it goes to 0, -1, and then it goes to 0 again. And so it has that nice little curve. All right, where it goes bing, bing, then it goes down here, like that. All right, so pi over 2, pi, 3 pi over 2, and then 2 pi. All right, so how does this change? How does this shift? Well, we see that we have some shifting going on here. So one thing we can do is really easy. We just take 2x minus pi over 6. So whatever's inside, and we set that equal to 0. That will help us to determine where is it being shifted. And so right here, we're going to take pi over 6, and then we have that equal to 2x, and then we're going to divide that by 2. And so we have pi over 12. All right, pi over 12 is going to be our phase shift. So everything's moving over to pi over 12 units. All right, pi over 12 units to the right. Okay, so pi over 12 units to the right is our phase shift. All right, right there. Now for our period, we look at our b value. Okay, that's our b value right there. And remember that our new period is going to equal 2 pi over b. And so in this case, we're going to have 2 pi over 2, all right, which is going to equal pi. So we have this new period of pi. Now, pi is going to help us, this period is actually going to help us figure out a second thing. I'm just going to put that in there right now. If you've watched my other videos, is that I like to use the quartile length um, to help us figure out our remaining new transformations. And I call this QL right there, okay? And how do you find the quartile length? Quartile length is always you take your period divided by 4 because it's divided into quartiles. So in this case, we have pi divided by 4, all right, which means that each quartile is going to be pi over 4 units. Normally, they're pi over 2 units. So every pi over 2 we add, but in this case, we're adding pi over 4. Now, finally, we're going to talk about our amplitude. Our amplitude is our a value, which is located there. Now, our a value right here is -1, but we always take the absolute value of a. And so, in this case, we're going to take the absolute value of -1, which makes it 1. Alrighty, dighty, oakley dokley. All right, this right here is our d value. This tells us where our midline is. All right, midline or the line of oscillation. If you watch my other videos, and then help us figure that out. That's generally it starts at 0, but in this case, our line of oscillation is going to be at 3. So our line of oscillation is going to be at 3 here. So what's happening? Well, we can figure out our new table by starting with our starting point. Our starting point is going to start at pi over 12. All right. And then with this pi over 12, we're then going to use the 0, and we're going to figure out what our next values are going to be. So if we take our outside values, we're going to take it 3 minus 0, which is going to give us 3. So we have our starting point. I'm just going to start making this graph right away. Okay. Is we have pi over 12. All right, pi over 12. And so what we have then is, how can we make this? So we're going to have force. So we'll go in, um, what should we have? Well, if we go pi over, yeah, we'll just go like this. Pi over 6. All right. And then we'll have another pi over 6 that'll be pi over 3. All right, we'll go pi over 2. All right, somewhere right there. Correct. So that's going to be 2. 3 pi over 6 is pi over 2. We'll have 4 pi over 6 would be, I'm sorry, 1, 2, 3. Then we have 4 pi over 6. And then we'll go with 5 pi over 6. And we'll go 6 pi over 6. And then we'll have 7 pi over 6. I think that probably will get us to where we need to go. All right. So now from here, we're going to be adding pi over 4 to each one of these. So we're going to find our remaining quadrants. Okay, so this is quadrant 1, quadrant 2, quadrant 3, and then finally we're going to get down here, quadrant 4. Okay, so we have 1, 2, 3, 4, 5 points. Now, in each one of these quadrants, we'll be adding pi over 4, our quadrant length, to receding value. And so, to get this next value, we're going to take pi over 12, and we're going to add pi over 4. Well, pi over 4, we have that, and so we have to get common denominator, so it's going to be 12s. And we're going to have this, which is going to be 3, so we have 4 pi over 12, all right, which is going to be pi over 3. Okay, we go then next one, we got to add another pi over 4 to that, all right. And so we have 4 pi over 12, 4 pi over 12, all right, plus a pi over 4, all right, so it'll be 7 pi over 12. And then from here, we're going to go and add another one. Okay, another pi over 4. That's going to be 10 pi over 12. Okay, and then finally we're going to have, for our last one, we're going to add another pi over 4, which is going to be 13 pi over 12. This is going to be our final answer there. All right, so for each one of these, we're going to have 0 or 1. All right, and so we're going to put our new values. So for this one, we have 3 when we add in 4 pi over 12, which is pi over 3. We'll have our 1 there, and so it's going to equal 2. And then we're going to have our 0 again, which is going to equal 3. Then we'll have a negative 1, which is going to equal 4. And then finally another 0, which is going to equal 3 again. Okay, and so we can see is that when we have our line of oscillation, we're going to have our highest value is going to be 4. 1, 2, 3, 4. All right, and we're going to have our line of oscillation, which is going to be a 3. Okay, so it's going to be 1, 2, 3. And I probably should move all of these values up. You can see this a little better. And so what we have then is when we start at pi over 12, all right, pi over 12 is going to be like right there. And we're going to be at 3. All right, then we go over to pi over 3, which is going to be over at 2, because we know our amplitude is only going to be at 1. And then we go over here at 7 pi over 12, 7 pi over 12. So this is 1 pi over 12, 2, 3, 4, 5, 6, 7. All right, and so we have that right there, which is going to be at 3 again. All right. Then we have 10 pi over 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it'll be 5 pi over 6, which will be at 4. And then finally 13, and we'll have that. So 1, 2, 3, 4, 5, 6, 7, 10, 11, 12, 13, and we'll end up at 3. And so you can see we are going down because we have our reflection right there, and then we're coming back up, and then coming back down again, and we'll just keep on repeating that little pattern as we go onward and forward. Okay, yeah, so as we do that, like that. Okay, we'll go down for a little bit longer there, probably. Yeah, there we go. All right, as we go. All right, so that's how we graph our graph right here. This is how we can get our points. Obviously, I can simplify these, but help us determine what our different values are going to be. Okay. Well, I hope this helps you out on how to graph a sine function, find its phase shift, period, amplitude, how we can use quartile lengths to help us figure out our different values. Um, yeah, and so on and so forth. All right. Well, good luck and God bless the rest of your problems.